In this video, we'll be looking at the limit definition of the derivative. The same limit used to define the slope of a tangent line is also the definition of the derivative. Definition: the derivative of f at x is given by f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x, provided the limit exists. The process of finding the derivative is called differentiation. A function is differentiable at x if its derivative exists at x. Notations that are used to denote the derivative of y equal f of x are f prime of x, dy dx, y prime, the derivative with respect to x of f of x, and the derivative with respect to x of y. A function is not differentiable when three things occur: when the function is not continuous, for example, our greatest integer function or step function is not continuous. So at those spots where it jumps from one y value to the next y value, that is a spot where the function is not differentiable. If a function has a sharp term, it's not differentiable. For example, f of x equal absolute value. We know that the absolute value function, the basic graph, is a v, and at that sharp turn, the function is not differentiable. And then also a function is not differentiable when the function has a vertical tangent line. For example, f of x equal the cube root of x. The cube root function has a vertical tangent line when x equals 0. So let's describe values at which f is not differentiable. For our first one, we have f of x equal absolute value of x squared minus 9. Now this inside part, the argument, is a parabola that goes down to 9, negative 9, and then crosses at 3 and negative 3. This is just the inside part. Well, when you put the absolute values around this, everything that's below the x-axis is reflected across the x-axis. So this part then comes up to here, and our graph of this function is this black curve. Okay? So we have sharp points at negative 3 and positive 3. So the question wants values at which f is not differentiable. So our answer would be when x is equal to plus or minus 3. For this one, we have a vertical asymptote at x equal 1. And so we have a graph that looks like this. So our function is not continuous at x equal 1, which means that it's not differentiable at x equal 1. And this graph actually, when x equals 0, y equals 0, so it actually goes through the origin. but it's still not differentiable at x equal 1. And then if we look at this graph on our calculator, x raised to the 2 divided by 5, we have a sharp point at x equals 0, so x equals 0 is the point where this function is not differentiable.